Good afternoon, everybody, and a very warm welcome to this first webinar of the DataBri-X webinar series. Today, as you see already on the screen, we have the first webinar that is called Data Process and Technological Bricks for Expanding Digital Value Creation in European Data Spaces. So that's more or less the subtitle of DataBri-X of our project. And today it's about governance and toolbar for European data spaces. We have two presenters in this webinar together with me. So very warm welcome to Stelios Saltsetakis and then also to Javad Javanara. I will introduce you one after the other before you go into your presentation. Just one small remark to the audience. We have after the presentations a Q&A session. So if you would like to raise questions, please put and type your questions into the chat. I'm very happy to take these questions and bring it to our presenters. And this is all for the introduction, so that we are for sure also, you know, totally who is on the line. My name is Martin Kaltenberg, and I'm one of the members of the DataBri-X consortium. And in the presentation that starts now by Stelios, you will learn more about the project itself, about the objectives, the use cases, and so on and so forth. So thank you very much, Stelios. The floor is yours.
Thank you very much, Martin. Good afternoon, everybody. I will go through the main parts of the DataBri-X project. We'll start by giving the area some introduction on the European data spaces and the European data economy. As we know, relies on the availability of data as the basis for further innovation and exponential development of the technologies, especially the development of trustworthy made in Europe AI that reflects the European values. The data spaces, which is a relatively newer concept, platforms and marketplaces are the enablers key to unleash the potential of such data. However, data sharing and data interoperability are still at their infancy. The diffusion of platforms for data sharing and the availability of interoperable datasets is one of the key success factors which may help to drive the European data economy and industrial transformation. However, the ambition to realize a cross-border, cross-sectoral data space and enable platforms to process proprietary, personal and open public data requires to overcome technical, legal and business challenges along the data lifecycle, which in addition to conventional raw data and its transformations along the processing chain also extends to metadata, models and processing algorithms. There is a need to rethink the data lifecycle practices around data sharing and propose a management model in the form of flexible data governance model that incorporates all relevant processes, including finding the right data and preparing data for sharing, improving the usability, discoverability of data. There is also need to advance the maturity of data tools and services, like for cleaning, aggregation, data quality improvement, creation and maintenance of common ontologies, vocabularies, and data models, etc., within the context of data sharing ecosystems. As the availability of integrated and holistic set of tools and technologies along the whole data lifecycle becomes as crucial as the availability of data itself. We also address issues such as data ownership, data provenance, veracity and verification, decentralized data sharing, confidentiality and digital rights management, processing energy efficiency, all need to be addressed appropriately. Such needs have to be addressed in full alignment with a strong legal framework for data and in support of EU policies, upholding values regarding democracy, privacy protection, and equality. The main objectives of the DataBri-X are to provide tools to support a holistic approach of the data lifecycle in compliance with FAIR principles that contribute to the minimization of the energy footprint, be adaptable to different user needs, and support and encourage new business models. Also, our objective is to build on results of relevant past and current initiatives that partners and people working in the project participated in the past and are active currently. Data management tools, systems, and processes that enable, support, and automate the creation and maintenance of common ontologies, vocabularies, and data models, as well as automated authoring, co-creation, curation, annotation, and labeling of data in view of the later uses in workflows, especially AI, made of the data. Also, to create links with the relevant initiatives collecting and using heterogeneous linguistic data. The project will also take care and mitigate the shortcomings of traditional waterfall lifecycle approaches. So it follows the JenPlane Data Governance approach that Javad will detail in the following presentation. This approach describes the data lifecycle like a plane instead of a cycle, which introduces a highly interactive and flexible lifecycle model. The JenPlane is enabling the users to select the most appropriate, energy efficient, and complementary combination of tools for their data management activities. The JenPlane process designer and composer answers the challenge of tool selection, collaboration, and orchestration, and cater for the need of semi-automatic deployment, execution, and orchestration of data incentive projects. The demonstration and work will evolve around 3 different use cases and trials. The one from the telecom operators sector, data operator data space, to accelerate the digital transformation of the operator and maintain effective use of data of revenue streams. There is a 3-tier digital strategy we follow: growing revenues from current services, growing strategic revenues, and reducing costs. The other use case is the energy data space that will develop and deploy the DataBri-X tools I mentioned within the energy community as part of the Aspen Smart City in Austria. And the third one is in the legal data space to promote ethical standards, legal compliance, and unbiased data, and the creation of core legal knowledge graph in order to be able to create smart services and tools on top of legal documents and other sources. In total, 11 DataBri-X partners are bringing 25 data tools and services together for different areas of the data lifecycle. The tools will be improved, advanced the TRL level, and finally integrated into the DataBri-X Toolbox that can be configured along the DataBri-X governance components to be easily deployed in data spaces. The consortium consists of 14 partners, companies, small and big ones around Europe, and research centers. The distribution around Europe is shown in this map from the Cordis European database. DataBri-X is an Horizon first call data project with a duration of 3 years that started October 2022 with an EU contribution of 4.7 million. And with this, I think I will give the floor back to Martin to introduce Javad for a more detailed presentation. Thank you.
Thank you so much, Stelios, for this great presentation and the insights into the DataBri-X project and what we're working on, what our objectives are. By the way, for everybody, Stelios Satsetakis is our coordinator of the DataBri-X project. So he's really at the core of everything that we do in this project, and he's a research director at Athena Research in Greece. Handing over to the second presentation I see on the screen, we have Javad Chamanara. Javad is a senior scientific researcher at TIP and at the Leibniz University in Hanover in Germany. And he will now give us insights into the DataBri-X governance process and beyond. So Javad, the floor is yours. Thank you very much and looking forward to learning about that.
Thank you very much. Hello, everybody in the audience and also other panelists. So you heard about the governance process, DataBri-X, workflows and so on a little bit, I guess, from the introduction that Stelios gave us. I will try to go into more detail, starting with a little bit of the story that where we started with that. In 2018, I published a very short paper about data life cycles. In that, I argued that data life cycles that I will introduce in a bit are not necessarily satisfying the requirements of the data-intensive projects and propose like a replacement or an alternative solution for that. In order to bring you to the solution that we are working on now, I will give you a little bit of history about that and the data life cycle that you may have heard about. So the first one that I guess everybody has seen is this circular data life cycle that was first introduced by Data1, that is basically creating some sort of working areas, like this working area, they call it discipline, I guess, like planning, collecting data, making sure that data is correct and fit, and then describe it using different technologies like semantic annotation and whatever, doing something for preserving that data, and then discovering the proper pattern or proper part of the data that is needed for the experiment or for the research, and then potentially integrate that part with other parts that you have also acquired for your work, then analysis or analyze that and potentially publish the result, and then do this circle. So it was introduced in order to make some sort of a structured, streamlined practicing of data-intensive projects, but people found out at that time that is not really complete and also is restrictive in a way. Like, for example, if I don't need to collect data and already have the data, then what to do? Should I do really something like a collect or even like assure if the data is coming from a machine like a lab machine or microscope and so on, then assurance here is not really of interest of that specific experiment. So people here in GFBio, as far as I remember, they provided some sort of this kind of shortcuts to give a customization facility to the user, so that if you want to jump from assurance to do some analysis first and then plan for the next iteration, you basically can do that. But again, here the problem is that this is like a cycle. You are able to create sub-cycles here, but still you are circular and you have to turn around that circle. So here USGS, US Geological Survey, they actually found out this issue and provided some sort of mixed solution. In that solution, some part of the work that you see on top is still circular or waterfall. So you plan, you acquire the data, you process the data, you analyze it, and so on. But there are some long-running and potentially never-ending activity that you also do during the project, like describing your data. So description can be done at acquisition time, at processing time, at analysis time, and so forth. Managing quality, doing administrative stuff like backup, security, and so on, they actually found out that they need two kind of activities. One is circular, that is in the direction of the research problem, and there are some that are work in progress that you should take care of them during the whole project. So this was actually the first time that that people started to think in non-circular data life cycles. So with that, then you see here DCC in the UK, they came up with the same concept, but they created this kind of layered, onion layered circular data lifecycle that based on the requirement, based on the nature of the data object, or based on the nature of the research project, you may create different cycles with different speeds. So let's say, for example, this inner cycle will iterate slowly, the outer one will iterate faster. So in this case, those things that are more research, innovation, and so on will iterate faster. But when they get mature, they go toward the core and get stabilized step by step. But as you saw, is that all of them somehow are geared toward iterative processes, but their iteration is somehow circular, so they are actually repeating. We changed that in 2018 to something we call it a plane. So plane here is like a Cartesian plane. So we have two dimensions. One is this horizontal axis that is actually a delivery axis, and the vertical one that is a discipline or working area. So we have 8 working area here, but in the latest version we have 10 working areas. So here basically you know that what you want to do, and then you distribute the work over this plane toward the delivery. But in order to make it a little bit more structured, we added something we call them phases. Like you have a conception phase. Basically here you are experimenting different options, different possibilities to come up with your method, to come up with your proper data, to come up with potential regulation of your research question and so on, and do a little bit of experimentation with the data and even with the tools. And then you switch your focus to implementing the actual data analysis pipeline. So here you will do the real implementation, you come up with your conclusion and result, and then you start preparing that result for publishing. So here you will do whatever that is needed by the publisher, for example, maybe in terms of formatting, in terms of metadata, in terms of preservation, in terms of even data paper formatting and writing and so on, or potentially DOI acquisition or minting and so on. And then you publish your work. When you publish your work in data-intensive projects, usually you need some sort of preservation as a proof of result, as a matter of reproduction, as a matter of archival, and so on. So you switch your focus to preservation, and then you will do some activities regarding the preservation, like, for example, if you want to deposit your data into a data space, or to like a well-known repository with metadata, with DOIs, with versioning, and so on, and with citation capabilities. So here, this is like a usual way of progressing, but at the same time, it also shows a timeline of focus in the project. So with this, then it's possible for us to actually place different activities. These boxes, this orange and colored boxes are activities that you need to do in the course of your project to actually to achieve the final result. So for example, here you can do some planning at the first, and then you can possibly repeat the planning in the implementation based on the result of your conception phase. And then after that, you don't do that much of planning. But again, let's say, for example, in the analysis, you will do some experimental analysis, and when everything is fine, you do the intensive analysis in the implementation phase, and then you possibly repeat them just to check if everything is okay at the beginning of publishing phase and preservation phase. But if you look at the preserve discipline here in the middle, you basically start with that when the implementation is done, and then the amount of work that you need to do for preserving your data and your output and potentially your methods and tools that you have used will increase in the publishing phase, and it will intensively increase also in the preservation phase. So this two-dimensional plane gives you the freedom to not only avoid circles, but also to give you to shift your focus. If you need to put more emphasis on, for example, on data acquisition, you are free to do that. If you don't really need to publish at all, you can remove this publishing phase, or you can enlarge that based on your experience in your team or your organization and so on. What else that it gives you is that for each of these activities, we have like a deep description in terms of semantic web technologies, which we explain what kind of a skill set is needed for this, what kind of tool set is available to help you actually realize this activity, and what are the guidelines to do these activities and so on. So you can you have like a project plan in a central place. You can estimate the skill set that you need, the duration that you need, potentially the people that you need to hire for this, or to swap them between the project and so on. So you get some sort of data intensive project management as a console or as a central place to work with JenPlane. Here is just the legend that you can play with this activity. So vertically, it means that how much effort do you need to complete the task. Horizontally, stretching it means that the duration that you need to complete the task. And also with the phases here, with this thick vertical black lines, it means that these are the milestones, so that you switch your focus from a phase to another phase. Each milestone has an exit criteria that you define it by yourself. Like, for example, with the conception, exit criteria can be that data is fit, method is fit. So it means that at that time you have to somehow guarantee, or at least make sure among the team members, that your methods and data are fit so that you can go to the implementation. But if you don't meet that criteria, you can potentially repeat the iteration. So here each vertical line inside the phase is basically an iteration. Let's say, for example, 1 month, 2 weeks, based on the size of the project, it can be varying. And if you need more time, you can basically insert more iterations into a phase, so they don't need to be equal. Some of them can be longer, some of them can be shorter, or even can be omitted in cases. So this is called JenPlane because it is a plane, and Jen is coming from the city of Jena, because this paper was published in the city of Jena when I was living there doing my PhD. So it's like a respect to the city. So then we actually put this JenPlane into the heart of DataBri-X. So DataBri-X is a system that is bigger than JenPlane. JenPlane is acting as the governance process, but we have some more important components that I will show you in a second. So DataBri-X basically is a collection of software tools. These software tools provide services for different parts, different segments, or different operations that are needed in data-intensive projects. These tools will need to collaborate with each other in terms of data flows or workflows, so that you can satisfy the requirement of your project. And then the idea is that to realize a higher level goal. This goal from the user side is the the data results, like you are doing an analysis or you are doing some experimentation and so on. But there is also some optimization objectives that we actually inject into the workflow, so that the workflow not only satisfies your requirement, but also some auxiliary objectives that I will mention in a minute. So with this, let's say this is the governance process. So there would be a website, for example, that you go register there. You can create your own JenPlane or JenPlane governance process. You will see this kind of processes there. You can customize them for your own purpose. And when you are done with that, then inside DataBri-X, as I said, there is an arsenal of different tools. These tools are integrated into DataBri-X overall ecosystem. With this two input, we basically have a recommendation engine that is looking at your process and looks at the tools and will give you candidate tools that can satisfy the requirements of your governance process. It's, for example, if you need to find some anomalies in a data stream, and if there is a tool here that will be found out and suggested as a candidate to this activity in the implementation phase for analysis discipline, for example. So basically, the recommendation engine is recommending you the services that are available in the tools, so that you can best satisfy your process. The idea here is that to maximize the extent of automated process execution here. So you design your process, we know what are the capability of these tools, and then generate a workflow for you, something like this. This workflow will give you the proper tools that you can actually put them together to run your pipeline. It will bind them together in terms of data input and the data output. So basically, it creates a data flow for you. It will also wrap all of those things into containers, like Docker containers, and packs them into a deployment package. This deployment package, later I will show you that it will be executed on a runtime system, like, for example, on a Docker Swarm implementation or on a Kubernetes cluster management, so that you can basically deploy that even automatically on the cluster. You can run it there, and then there are some built-in monitoring mechanism that you can look at the execution of your workflow. So this two main inputs, like the process that you design and the tools that we have, go to the recommendation engine. But the recommendation engine has also another input that we call them policies. These policies are basically optimization objectives. At the moment, we are focusing on these four objectives. One is for energy consumption, one is for cost reduction, one is for size reduction, I mean the size of the output data, and also for duration of the execution or performance in general. So in this case, it's possible for you to actually ask the recommendation engine to give you a tool selection that is best for energy consumption. If, for example, if your cluster is running on a energy budget, or if you are concerned about the total cost of your execution, here you can ask the recommendation engine to actually to optimize the tool selection for cost, so that, for example, if there are two tools that can provide the same functionality, but one of them is free, one of them is paid, then it will choose the free one, even if it consumes more energy, or if it's like less performance, which means that it takes a longer time for the process to finish. So based on this objective, that final workflow and the final recommended tool set will be different. So with that, this workflow that you see here will be packaged into something we call it the deployment package. Basically, this is like a comprehensive manifest file written in YAML. We ship that into a runtime here on the right, and that runtime will actually execute the whole workflow for you. And then, as I said, there are some built-in functionalities like monitoring dashboards that you can monitor the execution of your code. So here, this is like a very simple example of the deployment package. So you choose the, actually the recommendation engine gives you the suggestion. You have a little bit of like tweaking capabilities so that if there are two options for your optimization objective, you still have the final control to select or remove some of them. And then they will be Dockerized. Those Dockerized versions will be built into Docker images. They will be actually in the registry, or potentially they are already in the registry because we have a pre-populated registry of Docker images. And then when they are ready, basically they will be pulled into your workflow, and then workflow will be executed step by step. All the information that is needed for each step, like what kind of data will be the input, what kind of data is the output, where is the output container, and so on, are serialized in this manifest files, so that this is a self-descriptive package that you can even share it with somebody else. You can ship it to somewhere else for execution. Like if you don't have that cluster, you can ship it to somewhere in a public cluster or a research cluster if you are in a university or your enterprise and so on. Or even you can preserve this as a part of your project for reproduction later on by either yourself or third-party people. So this deployment package, as I say, like, for example, it can be a use case in our case, in our project, but it can be your own project. So this will be packed into deployment projects. They will be submitted to the orchestration or runtime execution platform, which we are using Kubernetes at the moment, but potentially Docker Swarm will be also supported in the course of the project. On this orchestration or runtime system, at the bottom is the cluster node that are actually doing the job, but there are some services like distributed services with file system, instrumentation, and so on, that you can actually rely on them. Let's say, for example, if your data is coming as a Kafka stream, if your data is coming as a S3 bucket and so on, or if you want your output to be serialized in a JSON that is saved into an S3 bucket or even into an IDSA connector and so on, you have some basic facilities on the cluster that you can rely on, and then they will actually do the job for you. So inside each tool, we basically have compartmentalization, like that at the outer layer, we have the container. Each tool comes with an API that is exposed to the outside world, which means that the tools that are going to communicate with each other, they will use this API to communicate with each other. And then internally, they have different services. Like if I have a language model that is able to do 3 different things, I will actually define 3 different services and expose those 3 different services through this external API. And then all the manifest files, specification, and so on will go into this green box here. We use this in the time of recommendation. So basically, we consume this part to know what is inside this tool, and then based on that, we come up with the recommendations when you are working with your process. So all in all, is like that. We have some people, we call them process designers. They will design the process. There are some policymakers that they will decide upon the policies, that it can be like per project, it can be per organization, and so on. And then there are some tool providers. At the moment, inside the consortium, we have 14 partners. I guess like 10 or 12 of them are providing tools. But this door is open for external tool providers too. So if you have a tool, you want to actually submit it to this ecosystem, you can go with that architecture that I just showed in 2 slides before to create your tool with the APIs, with the specification. It gets registered here. We do some benchmarking regarding energy consumption, licensing, cost, duration, and so on, to measure them. And then it will be registered in our repository here so that people can use it. So using these 3 items, we have this recommendation engine that is creating the suggestion and the deployment package. Deployment package will go to the workflow builder to bind them all together to create an executable workflow out of it. And then you can either preserve or execute that workflow, or even execute it twice or as many times as you want. So behind the scene, basically all this process definition and tool specification are modeled as RDF using semantic web technologies, which actually gives us some reasoning and inference power. They will be injected here, and the rest will be as I just explained. So you saw in one of the slides that I was talking about 3 use cases. Also, Stelios mentioned them shortly. So here I'm just giving you a glimpse of what a use case looks like inside DataBri-X, especially in terms of workflows. So the first one is a use case by Nova in Greece. What they are doing is that basically they are a network operator, like a mobile network operator. They are getting a lot of social data from their social channels. So they want to process those information. So the process of extracting information from the social data is modeled here as a very simple workflow. So they are using this pool party for filtering. Then they are using tweet horde for to process the tweets. They do dataset transformation. They should vocabulary definition, and then inject them as a knowledge base into pool party suite, and then visualize that. So this will be modeled as a process using JenPlane Designer. And then among the tools that we have in the toolbox, we will have something called pool party suite, tweet horde, and other tools. So they will be suggested as realizing tools for those activities on the JenPlane Designer. And then we get something similar to it as a workflow, which can be executed on Kubernetes cluster. If you are interested in the technology that we use for that, we are at the moment using Argo workflow, that is like a native language for defining distributed workflows for Kubernetes. And then that workflow will be shipped as a deployment package. So the second one here is the energy community by Siemens. What they are doing here is that they are collecting energy consumption and production of a community, like for example, a city or a district in a city. They collect that information, do some sort of validation on that, and then with the valid data that is coming from different sources, they do some sort of a simulation to see who, here is a household. Which household is a good candidate to buy energy from another household, and which one is the good candidate to sell the energy to another neighbor, for example. So they are basically trying to create a neighborhood market on energy. So if you have a solar system at home, but you are not at home this week or this time, they can automatically suggest it to those that have demand, and then sell your energy to a neighbor with the hope to create independent energy communities. So the process here is that data is coming from different sources, like from city, from ambient data, from weather data, from calendars, vacation, and so on. Do some sort of validation and registration on that data, do some transformation or acquisition of external data on that, and then run their simulation. With the simulation, they will get some sort of prediction, and then they analyze the prediction to actually to provide some sort of a plan, like who should buy and who should sell at what times and potentially at what prices. So this is also one of the cases that Siemens is working on. We want to actually to model this as a JenPlane process and also attach it to the tools so that at the end we have a deployment package that can satisfy the requirements of this use case. And the third one here, as you see, is a European legal database by Walter Kluwer. They basically have this kind of 3-segment federated data sources or data spaces, as they call it. So it's like the data spaces in different places, potentially for different countries or for different judiciaries. The data is there. They have, let's say, metadata storage, they have vocabulary, they have third-party interfaces, and so on. Then they want to create some sort of a connection between them and then apply some federated learning or overall learning on this type of data to create legal data products. So in this case, again, we want to model this as a JenPlane process to check if we have all the tools that are needed for this, or we can actually build the tools that can satisfy the requirements of these things. And then at the end, we also have a deployment package that can actually satisfy or realize to the best extent the requirements of this European legal data space. So I guess I'm done with that. I can stop at the next slide here and back to you, Martin, for the rest of the webinar.
Thank you very much, Javad, and yeah, great presentation. I know it's always hard to keep the balance between technical details and giving an overview. I think that was greatly done to get an understanding of what DataBri-X and JenPlane, or JenPlane as you call it, can do for us. So thank you very much. So in principle, we go into the Q&A session here. And still the chats are open, but I pick, I would say, at least 3 questions now for you, for our panelists and presenters. That I've noted down from the chat. So one is, oh, that's an interesting one. So somebody's asking, can I and how can I bring a tool to the DataBri-X system? Is that possible, or is that a closed environment?
So from the consortium perspective, I guess Stelios can answer that, but from technical perspective, we have a specification for each tool. That specification means that you have to, in RDF, in semantic web technologies, you have to explain what the tool provides. You have to at least give an executable version of that code to us for benchmarking purposes, so that we have to benchmark it on a standard system for comparison of duration, performance, energy consumption, and potentially cost. And also you have to define the licensing per case, and then we wrap all those things together, and then it will be registered into the toolbox.
Thank you very much, Stelios. Would you like to give a note? In addition, is it possible, as I think you're muted still, is it possible as a non-consortium member to bring a tool into the DataBri-X toolbox?
As it is structured now, and since we are in the first period of the project, we haven't seen that or demand for this, or we don't have something in the structure of the project to handle these requests. But we are open to, as we mature and give the first demos open for people to test, to somehow onboard users for testing. As for the business model of exploitation of the results at the second part of the project, certainly we have to provide for that. but that depends on the partners, how they define the participation of third parties to their work. Actually, as a European project, the results will be open and anyone can reuse. But for the specific setup we are doing, the specific Kubernetes installation and the execution of the use cases and trials we specified, somehow this external participation is limited. But we will provide as we go along for this. It's very interesting, and we want to have demand for that. Thank you.
Absolutely. Thank you very much. Yeah, and in the chat you have also our website. So if you're interested to get in touch, just go to the website and contact us. We're happy to have a discussion also on this topic. A second one, I think, yeah, Javad, it's also good if you can take it. It's about, you speak about integrating it into data spaces. So can you explain if and how this is following IDS standards or something similar? And are you using connectors? And if yes, which ones?
Okay, so we are, I mean, we as a TIB are not directly using connectors, but yes, that is one of the ways that we integrate. Is like that if your data is outside and you don't want to bring it in, one way is to use the data space technologies using connectors. And also if there is a remote function that is already registered there, that would be also a good candidate to get it into the toolbox. But from our side, we also provide some connectors. I mean, some of the partners are building connectors so that if there is something in our DataBri-X toolbox that is interesting for others, they can also use it through the connectors. Which connector we are using, I'm not really sure at the moment. Potentially, Martin, you know that.
Not in detail. I think we're using something in between, and then we go for the Eclipse data space connector that is becoming more and more a little bit the center. So it's this EDC that at the moment that you can find outside. Stelios, you would like to add something, or are you good?
Yes, exactly, Martin. This is what is done right now. We are trying to follow the tool, the connector that has the most active community behind supporting, so we are not left alone. Since we are not doing the technology, we want to follow the one that will be used by other data spaces also. And in terms of using the connector to access the language data space, I know that the people are already working with Eclipse. It is a decision that they took already outside DataBri-X. So we're going to be following this type of connector technology for our work now.
Absolutely. Thank you very much. You raised it. Maybe one line from my side for everybody. We are also developing in the consortium a connector to the language data space that is established at the moment, European language grid called before. And here then we at DataBri-X, you also can load resources from this language data space, also models and others. So that was a very good point that you brought up. We have more questions. Let's see. Let's fetch another one. It goes to Javad for sure. How do you validate the tools? I think you explained a little bit, but maybe that's more in-depth.
Yeah. So as I said, we only have a benchmarking mechanism. We don't really look at we don't look at two things. One is that whether the tool is doing what is promising, and also we don't look at what else the tool is doing. So maybe you promised you are doing A, but in addition to A, you do B also. So we don't really look at that because at the moment it's like a trust-based mechanism here. And also we rely on the end user. If they see that this tool is not going actually to satisfy the requirement of their activities, we will get some sort of a feedback from that. But internally, we don't do validation. The only thing is we do benchmarking, and this is for our recommendation engine.
Absolutely. Thank you very much. Let's pick a final question here from the list that is also interesting. Not sure how we can or if we can answer in totally detail. You mentioned vocabularies in the introduction. I think that goes to you, Stelios. And it says, will the DataBri-X vocabularies be openly available because they are part of, let's say, interoperability. So not sure who wants to take it. Stelios, will the vocabularies developed in DataBri-X be available to somebody else or parts of it? Or
in what way? I just don't understand. I mean, how being available as in public domain? I'm not sure. I don't know.
I think it's about reuse. Yes, the question is about reuse, if it can be used, or it's a closed engine more or less that only the use cases can use it, or they're somewhere else hidden.
As you know very well, this question about vocabularies is very tricky one, because everything is very domain specific. As you try to use the energy space vocabulary in I don't know, another type of data space, completely irrelevant, like the automotive industry. I think it's some parts are common, but there is a lot of differences, and I do believe that there will be kind of different. But if someone wants to use something that we develop, vocabularies that are out of our cases, that will be possible, I believe.
I believe so too. I think maybe there are some parts that are more or less confidential from the industry partners, but main parts will be open, I guess, and we're happy to share also in the course of supporting interoperability. Good. I think we here can call it a webinar. I'm not sure if we have a slide, but the audience guide to the next 3 webinars that are ahead of us. So we come from this introduction webinar that we're doing today to 3 use case webinars. So the next one will be on the 24th of October, 3 p.m. Central European Time. It's about the legal data space presented by Wolters Kluwer. We will then have on the 2nd of November, 3 p.m. again, the telecommunication use case presented by our colleagues from Nova. And the third one will be on the 23rd of January 24, so already next year. Time is flying. The energy use case by Siemens that has been explained. Everything is on our website. Also the link to the webinars you can find directly on our website. And everything is open at the moment. To me is thanking Stelios and thanking Javad for great presentations. And thanking the audience for taking the time to be with us. And we'll share the slides and the recording on our website in the coming days. And thank you very much. Have a great day, a great week.
Great.
And see you soon.
Thank you.
Goodbye.